Hi, Mrs. McTaggart here. So in this video we're looking at quadratic theory and we're going to look at the discriminant. It's a very important part at higher maths, worth an easy couple of marks if you remember it. Now this is very similar to National 5 to be honest, because it didn't used to be in National 5 until a few years ago. So let's have a wee look. So for any given quadratic, i.e. something with an x squared in it, right? When you have equal to 0, we can calculate the discriminant. And if you remember, the discriminant helps you determine the nature of the roots. We also use it a lot higher to prove if something is a tangent or not, okay? So it mainly to do with nature of roots, but tangency as well, and you'll see that further on in the topic, but it's worth mentioning it just now. So there's 3 possible scenarios, and you need to memorise these. You should already know them from National 5. The 3 scenarios are, when it is less than 0, that means you have no real roots. So in terms of a picture, you've got some kind of quadratic and it doesn't ever cut through the x-axis, so no roots at all, okay? Now sometimes you're asked in a polynomial question to show that there's only maybe one solution, and then you're left with your quotient from the polynomial doesn't factorise. But to prove that it doesn't factorise, if you do the discriminant and get your value less than 0, then that means it doesn't factorise and it means there are no more roots to that equation. So it comes in there as well. The second scenario is when it equals 0. Now this is the important one. When it equals 0, that means you've got a one repeated real root, or one real root repeated, depending on how your teacher phrases that one. Now that means your quadratic is sitting on the x-axis, it's touching, it's got one point of contact to the x-axis. And when it comes to doing tangent questions, remember a tangent is like the ground. The circle touches the tangent in one place only. And sometimes you're asked to prove a line is a tangent to either a curve or a circle. And to do that, again, you can do the discriminant. And if you get your discriminant equal to 0, well, that means one repeated real root or one point of contact only. All right? And then, and the last one is when it's greater than 0. Well, that's your dream scenario when you've got 2 real and distinct roots. Now, you have to watch the words here. If you're doing a statement, you must write these definitions exactly, particularly this one here, 2 real and distinct roots. If you just say 2 real roots, not getting your mark. You have to have the word distinct in there. And that should have been hammered into you at Nat 5. So let's look at my examples. First one says, determine the nature of the roots of this trinomial here. So remember, your a value is the number in front of the x squared. So a is 2, b is the number in front of the x, and c is the number at the end. So if you're working out b squared minus 4ac, well, b squared is 16. Take away 4 times 2 times 5. Now that gives you 16 take away 40. And 16 take away 40 is negative 24. So your discriminant is negative, no real roots. So you have to write b squared minus 4ac is less than 0, so no real roots. Okay, and remember what I said, that could be that extra wee bit near the bottom of your polynomial, it's your quotient. You have to prove that there's only one solution, you can't get any more from that because you've sat for half an hour trying to factorise it. Remember, discriminant proves that it doesn't factorise, it means that there's no roots. Go do that wee bit of working as your proof. Right, my second example, this layout is all wrong. You need to have it in the form everything on the left hand side, right? So we're just going to rearrange this one. So make this 7x squared plus 5x take away 1 equals 0. Then we can just do the same as the one before. So a is 7, b is 5, and c is negative 1. So b squared minus 4ac will be 25 take away 4 times 7 times negative 1. So that becomes 25. 4 times 7 is 28, there's a double negative there, so it becomes 25 plus 28, which is 53. Now in this scenario, we have a positive answer, so b squared minus 4ac is greater than 0, so we have 2 real and distinct. Don't forget the word distinct. Distinct means they're very different, right? So 2 clear, different roots, okay, not matching. Then you have these ones, right? And the difficulty of these changes depending on where they put the unknown value. The unknown value could be in front of the x squared, in front of the x, or the number at the end, and some are definitely harder than others. So this one, it tells me it's equal roots. So the minute you hear someone talking about the nature of the roots, it's discriminant. So b squared minus 4ac is equal to, is equal to 0. I got a bit flummoxed there. Equal roots means your repeated root, equal to 0. Then you sub in. So at the side I'm just going to write down. So a is p, b is 4, and c is negative 2. So what we have here is we have 4 squared is 16. Take away 4 times p times negative 2 equals 0. So you've got 16 add 8p equals 0. We've made a wee equation, let's rearrange it. So 8p equals negative 16 and p equals negative 2. So when p takes the form negative 2, then this thing here will have equal roots. Okay, so my last example says, show that this lovely looking trinomial here has real roots for all values of m. Right, so it's talking about the roots. So I'm going to go do my b squared minus 4ac and see what comes out, right? So a bit more complicated than this one. A is this thing here. It's 1 plus 2m. B is negative m. And C is negative 2m. So we're just going to plug it in as normal. Going to be a wee bit of algebra work here by the looks of it. So b squared minus 4ac will be, right, negative m squared minus 4 times that bracket times negative 2m. Right, well, negative m squared is just m squared. If I multiply this out, I'm going to do the 4 times minus 2 first of all. So this will give me a plus 8m that I then have to multiply the bracket by. So I have m squared plus 8m plus 16m squared. Now if I rearrange that, I then have 17m squared plus 8m. Right, now I'm looking at this thing and I'm thinking, right, okay, I have to prove that this has real roots for all values of m greater than 0. So what it's saying is, if I plug in any values of m equal to or bigger than 0, what will come out? So what happens here is when you plug into m squared, anything there you plug in will come out positive. So this bit will always be positive. This bit here will always be positive as well because you're plugging in a positive number. So anything I substitute in here is going to be greater than 0. So all you then have to write is b squared minus 4ac is greater than 0 for all values of m greater than or equal to 0. And I would just say since, I'm running out of space here, and I would just say the reason for that being is since 17m squared plus 8m is greater than or equal to 0. Okay, so hopefully you've understood that. That last one was a wee bit tricky, but it was good to show you one with harder algebra to substitute in. So if you have access to a TJ Higher textbook, this is the questions I pick and choose. There's lots of repetitive questions here. You don't need to do every single one, but for some reason I've liked those ones. Anyway, hope you've enjoyed watching. Hope you understood these okay. Thank you.